Whew! After that integral test, I needed a break. Man, that was killer. Look at that thing. All these other tests are pretty easy, but once we get to that integral test, it's a lot of work there because of the improper integral. So those are always a lot tougher to work with. So be careful. Go back and try that one again. That's about as hard as I've ever seen them. All right, but let's take a look at number 12. Now, number 12, this looks kind of difficult when you first look at it. We got this 1 over 3 to the n plus 1. But remember, we're dealing with as n goes to infinity. And as n goes to infinity, this 1 really doesn't matter. So this was one of our comparison problems. We're going to see another one later on. For comparison, I can let my b sub n equal this 1 over 3 to the n right here. So that's my direct comparison, and that's what I'm going to check as n equals 1 to infinity, 1 over 3 to the n. Now, this doesn't look geometric the way it is, but if I factor out that 1/3 here, I get 1/3 to the n. So I know that my ratio is 1/3, which is less than 1. Don't forget, you want to talk about the magnitude of it, because sometimes this might be negative, and it's the same idea. You want that magnitude to be less than 1. So this will converge by p-series. Now, we're not done yet, because now we have to compare them. Why they call it a comparison. So now I'm going to compare the original a sub n and b sub n. So we got to remember, if b sub n converges, in order to guarantee my original converges, it must be less. Or equal to, I guess. Less than or equal to. So let me say that again. This is very important. B sub n converges. And converges means that it is approaching a number. It approaches a number. So B sub n is going to be finite. It's going to end eventually. We don't know where, but we know it will end at one point. For a sub n to converge, to guarantee it converges, it must be less than b sub n. So we check it. 1 over 3 to the n plus 1, less than or equal to 1 over 3 to the n. And I know this is going to be smaller because my bottom is bigger. Because I'm adding, I know that my bottom is bigger here. Because I'm adding 1 to it, which in fractional terms, which means that this number is going to be less than. For example, 1/5 is less than 1/4. So this checks out okay. So therefore, we would say our series converges by direct comparison. Right there. And there we go. Very easy to do. All right, number 8, this is one of our new ones. This doesn't really fit any of our rules. And because of that factorial right there, I know this is going to be hard. This is our new one. This is that ratio test right here. This is that ratio test that we talked about the other day. So for the ratio test, remember, it's saying take the limit. We're comparing the ratio as n goes to infinity of a sub n plus 1, the next term, over the previous term. So let's kind of review what this is really saying right here. We're saying we're comparing the next term, it's the next, over the previous. And if I list it out, like 5, 4, 3, 2, 1, let's say I use my terms, this would be like my a sub n plus 1. This would be like my a sub n. So I'm comparing them, 4/5, 3/4, 2/3. And what you want this value to get smaller. As it's getting smaller, it means I'm approaching 0. It's approaching a smaller value right here. Now, for this, if it's getting smaller, in other words, if this ratio is less than 1, because it's getting smaller, we will say this converges. Greater than 1, it will diverge. It won't ever equal 1. If it does equal 1, we have a whole other set of problems. We'll talk about that sometime. All right, so let's check it out. We're going to take the limit as n goes to infinity. This becomes 5 to the n plus 1 over n plus 1 factorial, mess that up, divided by the original, 5 to the n over n factorial. If I invert and multiply, we're going to get this 5 to the n plus 1 over n plus 1 factorial. Flip it, n factorial over 5 to the n. You're going to see this later on. This is going to be a big part of when we get to Taylor series. And I just use a bit of algebra. It goes a little bit away right here. So if we take a look here, if I take 5 to the n plus 1 over 5 to the n, the 5 to the n's cancel. If I subtract them, the n's subtract out. And we're left with 5 on top. I can expand the bottom here, n plus 1. N factorial, those will cancel. And I'm left with n plus 1. And if we let n go to infinity, we get 0, which is less than 1. Therefore, the series converges by the ratio test. This is a big test for us. We're going to see this one quite a bit next unit. All right, next one here. All right, let's take a look here. Oh no, this is another comparison test. I can tell just by kind of looking at it. I mean, some people say, can we use the ratio test? Yes, the ratio test will work here, but you'd have to square it, n plus 1 squared. N plus 1 squared just becomes kind of a mess for us. So it ain't worth your time. So I do prefer to use comparison, and by looking at it, it's going to be the limit. So I'm going to find my b sub n. As n goes to infinity, that 5 doesn't matter on top, so we get 2n squared, and on bottom, 3n squared. Actually, it's even easier than that. This is just my limit test, isn't it? Oh my gosh, Mr. Warren, I messed this one up. I don't have to do that one. Because on the original problem, that was a 3 right there. Sorry about that. That should be a, let me see this again. That should have been a 3 right there. All right, so let me see here. There we go. Otherwise, it's just nth term test. Sorry about that. So if I simplify this, this becomes 2 over 3n. And I can write that. That's my comparison. As n goes from 1 to infinity, 2 over 3n. P is 1 right there. So therefore, this series, this diverges. And you can say because it's harmonic, or if you're lazy like me, P series. All right. So it diverges. So now I am not going to try. Remember, for diverging, if you want to compare, if you want to do direct, you have to say a sub n and b sub n. You want it to be greater than, because if b sub n goes forever, if you guarantee that a goes on forever, it has to be greater than b sub n. But do you really want to see if this is greater than this value? I don't think so. So I'm going to try my limit comparison instead. As n goes to infinity, remember it's going to be the original 2n squared minus 5 over 3n cubed plus 4n minus 6 divided by b sub n. So I'm going to go ahead and invert and multiply. That's just 3n over 2. And this becomes just, what's that? 6n cubed over 6n cubed. So that just becomes 6 over 6, which is just 1. So this is finite and positive. Therefore, we can say the series diverges by limit comparison. Whew! Alright, so going to video number 3, we're going to take a look at some of the word problems here, okay? I'll see you then.